Welcome to the third video in our series. In this part, we want to rotate each individual floor. To rotate geometry, we can simply use the rotate component. I will open the search field and get it by using the according keyword. I will use this method more often from now on, since it is much more convenient than navigating through the interface. However, if you want to know where a component is located, you can always press and hold Ctrl and Alt while clicking on it. Let us continue by plugging the output geometry of our move node into the first input of our rotate component. This will rotate our floors by 90 degrees. If we hover over our angle input, we can see that it is related to its default value. Let us change the rotation value by creating a number slider. I will show you a simple trick to save some time. If we open our search field, instead of using a keyword, I'll simply type in -180 is smaller than +180 and press enter. This will automatically create a pre-configured slider for us. Let's plug it into the angle input of the rotate component. To have a better view on what's going on, I will turn off the preview of our move component for now. If we now use the slider, we can see that the rotation is not really working as we might have expected. This is due to the fact that Grasshopper interprets angle values by default as radians, not as degrees. To adjust this, we can simply do a right-click on the angle input and select degrees from our option menu. A little icon will indicate that we changed the input setting. If we now use our number slider again, we can see that it works as intended and rotates our floors between -180 and +180 degrees. However, as before with the movement component, we also want to be able to adjust the rotation of each floor individually. But before we continue, I'd like to quickly address the third input. This is the rotation plane that defines the rotation axis by using the z-axis of the input plane. By default, this value is set to the world's xy plane, which works just fine for our floors. However, if you would like to define a custom plane, you can simply use the construct plane component or choose another predefined plane like the YZ plane. I will remove those components again since we don't need them right now. To give each floor its own rotational value, we can use the remap numbers component. Let us get one into Grasshopper. As you can see, it also comes with 3 inputs. The idea behind the remap component is that we input a list of numeric values and adjust them to a new range. The first input defines the list of values we want to remap. In our case, this will simply be the increasing number of each floor level. Let us quickly create a series component for that. This time, I will leave the start and step input as it is and only plug our floor count slider into the count input. In this case, it will give us a list of 25 values, one number for each floor level. Let us plug it into the value input of our remap numbers component and look at the second input. This defines the range of our input values. In Grasshopper, ranges are called domains. So, in case of our value list, the smallest value is 0 and the biggest value is 24. To calculate the range automatically, we can simply use the bounds component. It will take in any list of numeric values and return to us the correct domain. Let us plug in our value list and connect its output to the source input of the remap numbers component. If we now hover our cursor over the output, we can see that we get a new list of 25 remap values. To illustrate this more clearly, let me quickly create 2 panels and place them next to each other. As you can see, each input value was converted into a new number smaller than 1. This is because the target input of the remap component is set to a domain of 0 to 1 by default. I will quickly turn down the floor count to 11 so it's more easy to understand the conversion. So, our input value list now has a domain from 0 to 10, while our target domain is still 0 to 1. The smallest number in our original list is still 0 in our remapped list, since this is the smallest value in both domains. However, the biggest value of 10 in our original list is converted to the biggest value of our new domain, which is 1. In the same way, all other numbers are remapped relative to their position inside of the domain. Actually, we do the exact same thing in our lives when converting values between different units. For example, 1 centimeter can be mapped to millimeter space, which would convert it to a value of 10. Let us continue by adjusting our target range to a custom domain. As before, we want to map all values to a range between -180 and 180 degrees. For this, we can use the construct domain component. In general, all components related to domains can be found in the math category. I will select the construct domain component and place it next to our remap numbers component. Let us create 2 panels, one with a value of -180 for the domain start, and one with a value of 180 for the domain end. If we open the search field, we can easily create a panel with any value by using quotes and confirm it with enter. I will connect both panels to the construct domain node and set it as a target domain for our remap component. As you can see in our text panels, all of our input values are now converted to the correct domain. The last thing we need to do now is to connect our remap values to the angle input of our rotation component. Also, I will crank up our floor count again. And there we go. Each building level is rotated individually based on its position. That's it for this part of the series. I hope you liked it and could take away something from it. As usual, I'll do a quick cleanup of the canvas and then see you in the next video.